Hello there, it's Jay here from Jay's Vintage Junk, and well, to be honest, today I was meant to be in the back garden messing with my biodiesel project, but I've just been rained off quite severely. 1 minute it's beautiful sunshine and I get everything set up and ready to start processing some veg oil, and the next second it's hailstoning, so I've decided to put that on hold and I've come back into the workshop. And I'm pleased to say I have made some progress on the video output for the Amstrad PC1512 project. I just kicked the camera stand, but if I just spin you over a little bit so you can see the screen, I'll zoom you in. Apologies for the flicker because I am filming a CRT here, but if you look there, we've got nice, reasonably crisp actually for displaying on an old TV, but we've got faulty floppy drive controller or error. I mean, it's slightly off the screen, it's not quite perfect, but at least it's readable. Like I say, error, faulty floppy disk controller or disk drive. So we've proved the board is 100% boot into that point, and more importantly we've actually figured out what the issue was with the video, and I'll get you down onto the desk here, and I'll show you basically what I've found and what I'm going to actually build. I've actually decided I'm going to build two adapters. I'll go into that in a little bit, but I'll get you down onto the bench and we can have a look at some pieces of paper and some circuit diagrams and what have you. So back in a sec. Right, okay, I've got you down onto the breadboard. Now, ignore this bit here because that's for something else. That's that LM1881. But basically what Gadget UK actually put a comment up on my previous video on this, mentioning about the capacitance issues with these breadboards, and was that perhaps what was affecting the signal. And I think that was actually certainly playing a factor, for the simple fact that when I was messing about with this circuit, where I placed my hand over the circuit actually affected what was happening on screen. And that's due to the fact that basically you've got rows and rows and rows of copper tracers in here. And when you get two metal plates close together, you basically form a capacitor. So the board does have capacitance to it, and just your hand going closer will actually vary that capacitance. That's actually how, have you ever seen a theremin, the musical instrument, a theremin? That's basically how they work. It's your hand basically altering the capacitance, which changes the resonance of a circuit. That's how, like I said, it's a long time since I've played with theremins. I did build one when I was a lot younger than I am now. A valve one out of a circuit from the 1930s. Yeah, I think it's basically that's the same thing was happening here. But so first thing I started to do, I thought, right, I wonder if that is the issue. So what I thought I'd do, I'll split the circuit up and see if we can eliminate the issue with the capacitance. So what I thought I'll do, I got another 7404 and I put it on the board over here. And I thought what I'll do is I'll use one gate from that one to do one job, and another gate from this one to do the other job. So I thought, right, I'll use, because I'm only messing about at the moment with the just the single green signal. I use that 7404 there to invert the green, and this one to invert the sync, and exactly the same. There was no difference in it whatsoever. So anyway, it was actually just me fiddling about. I bypassed the with my scope probe. Actually, it was quite by accident. I was probing the input and the output of the sync, watching it on the scope, and I caught between the two pins with the scope probe, and I just out of the corner of my eye on the screen over there, I actually saw. I got a perfect picture. It locked, and I took my scope probe away, and it was back to drifting. Thought, right. So basically I took the composite sink that's coming straight off the Amstrad board and I've put it straight into the monitor, so it's not being inverted by the circuit, and it works perfectly. So that's weird. So you see, in the Amstrad circuit they use in the monitor, all the lines, I think all the lines, in fact I'll just get the circuit diagram up here now. Sync, red, green, blue, intensity and the black signal all go through the 7404 and get inverted. So there must be something in the Amstrad monitor that actually needs that signal different from normal. So basically it comes out of the Amstrad computer as a normal sync signal, and it's actually the monitor itself that needs that signal inverted, and that's what the 7404 is doing. So like I said, what that means is basically I don't need to use one of the gates on here. I don't need to invert that sync signal. So what I've come up with, and this is what I'm going to build for my first circuit. Let me see if I can get that in focus for you. Can you see that? Can you all read that? So this is incredibly simple. This is basically how I'm going to get a colour picture onto that little CRT TV I've got up there. So we've got the intensity signal, and we're doing like we've done to get the gate to actually work. So we've got a 100 ohm resistor and a 75 ohm resistor. So the 75 ohm resistor goes to ground, the signal comes through the 100 and into the first gate, out of the gate. That's our intensity signal, and then that goes through a 1k resistor down to each of the red, green and blue. Then we've got our red, again, goes through exactly the same thing, 75 ohm resistor, 100 ohm resistor, into the gate, out of the gate, into a 56 ohm resistor, and then that connects obviously to the 1k resistor from the intensity signal, and that's our red. So we repeat that 3 times, and our sync just goes straight through. So I've not bothered about this black. I believe from what I've read up, this black pin is more to do if you're just using a black and white monitor. I think it connects to a part of the contrast circuit in the black and white Amstrad monitors, and I don't think you really need it if it's a colour monitor that we're working with. So I don't think I'm going to, famous last words this, I'm not going to breadboard all this up, because I've used this part of the circuit before. I know that works. From what I've just done with the green there, we know that works, and all we're doing is we're doing that 3 times. So what I'm going to do, I might just try and see if I can, because I don't like wastage, I might see if I can just recycle that board, so I can clean off what I did on that board, and we'll reuse that to build this little circuit. So I'll clear the bench off a bit, and we'll have a look at actually putting that together. So back in a sec. Okay, we're back, and as you can see I've cleared the desk off a little bit. I've just spent 10 minutes off camera just getting all the old components out of that, and I think we can probably reuse it. As you can see, I've not got it perfect, but we've got all the holes unblocked, and there's a couple of traces that are slightly lifted on it, but I don't think it'll matter. I think we can still reuse that and save myself wasting a board. I've just had a quick trip into the attic into my junk stock and just pulled that out. I'm thinking that might make a nice enclosure to mount this in, make it look a little bit better than just having a bare board flopping around. So we'll open this up first and we'll have a quick look, see if this is going to be suitable as a enclosure. I do have something else we could use as well, but it would involve either cutting that board down to fit or using a different board. Let's see if I can get this foot off. I guess, or I've got a screw. No, there isn't a screw there. They are. I think the screws for these are under the feet. At least I hope they are. Is it just clipped together? If it's clipped together, it mightn't be any good to us. Is there a screw under there? Feels like there is. Tell you what, these feet are stuck on. There's no bloody... Oh. Oh. Well, we're going to have to find a foot for there if we want it to sit square, but... Right. This might not be suitable then. We'll see if there's enough room inside it to fit that board in. If not, then we'll have to look at something else. Even use a hex screw there. I mean, this is useless. It's an old DSL modem. You know, before, you know, when you had one computer connected to high-speed internet. There we go, we're in. We're going to have enough room in here to get rid of that board. What do you think? That might work. That might just work, that. Yeah. It actually holds it in there quite well. I have to trim some of them bits of plastic down to get that to fit, but I think that's actually going to work. Look at that. So at least we've got enclosure for the project. Right. And what I'm going to do, I'm not going to make the mistake I made before and offset the IC. I'm going to put the IC right in the middle there, I think. I think that'd be the best thing to do. Where's my pot of IC sockets? And some wire. No, is that the right size? Where's the 74 series IC? I can just see, make sure these are the right size. That's the right socket, isn't it? Yeah. Because I actually had the wrong size socket on here. It was one too big, because at the time I couldn't find these. I mean, these are cheap, nasty sockets, but they'll do for this. Get one of them off. Okay, there we go. Put them away. We'll put that back there into harm's way. Right, let's get that IC socket mounted first. That's what I always like, to mount my IC socket first when I'm doing something like this. It gives me something for basically to build off of. I think we've got a blocked, yeah, we've got a blocked pin there. Have we? Are we in? We're in. Oh wow, we're in. Right, what I'm going to do, I'll bend over a couple of pins and I'll solder the IC socket in place, just so we know it's secure. Okay. Get you down a little bit so you can see what I'm doing. There we go. So like I said, there is still solder on this board because I'm reusing the board from the previous attempt at this. I've just cleaned off as much as I needed to. But we'll just try cleaning my iron. I'm really losing it today. I've switched my hot air rework station on, not my soldering iron on. It's stone cold. Just bear with us for a few minutes, folks, while I just let my iron warm up. So, back in a sec. Right, okay, that's better. The soldering iron's actually heated up this time. And we'll just solder those outer IC pins just to hold the IC socket down in place. Okay, there we go. Right. So that's the IC socket. Oops, I'll get you out a bit. One of these days I'll hit the right zoom on the camera. Right, so there we go, I've got the IC socket in place there. So that's going to need +5 up there. I'm going to need a ground connection there. I'm going to need some more grounds. We're probably going to use one of these down here as a ground actually. So what we could do, yeah, what we'll do, we'll use those two centre connectors there as the +5 and the ground. That'll make life a lot easier. That'll give us plenty of places we can connect on to the ground. We only need the 1 +5 to run the chip, but we do need to connect plenty of grounds up, so that'll give us a nice run of grounds to connect everything up to. So, where's that IC gone? There's our that's a 7414, I think, but doesn't matter for this. So that will go in there like that. That pin up there is VCC, so that's +5 volts, and that pin at the bottom there is ground, so that's needs to go to the ground point. Right. Spin that back over. I suppose the easiest thing we can do is just make a little solder bridge. Like that. Is that bridged? So I could use a little piece of leg or something. What forgot? Oh, there we go. We've just about managed it there with a, have we? Yeah, there we go. Just bridge those across there, so that's basically we can put 5 volts in at the top there, and we can use that one as the ground, which is, which pin are we on for the ground? That one there. So basically we'll do the same there. Let's see if we can just bridge those two with a little bit of solder. Fortunately they are really close, so it is kind of easy to do. Yeah, that's bridged quite nicely there. So that means, like I said, we can put 5 volts in there, we can put ground in there, or 5 volts there and ground there, and these, all these rails in the middle there are that, which will make life a little bit easier for us. Right, let's start getting this. So basically what we've got to do is build that on there. So we're going to need, between the gates, now there's a gate there, a gate there, gate there, there's a gate there, a gate there, and a gate there. So on the input for intensity, we'll use the first one up there for intensity, make life easier. So we're going to need a 100 ohm resistor between that pin there and the next point. Let's see if I can see a 100 ohm resistor up here. just bear with me a second, folks. I'm actually just going to have to go and grab some components because I thought I'd got enough bits out on my table here, and just realised I haven't actually picked any 100 ohm resistors up. So back in a sec. Okay, sorry about that, folks. I think I've got everything we need here now. So we've got the 1K resistors and the 560 ohm resistors that we salvaged off the previous incarnation of this board, and in addition to that we've got 4 75 ohm resistors and 4 100 ohm resistors, which is basically this bit here, which is what we didn't have before, and which is why the 7404 or 7414 was not actually doing its job. It wasn't working, it didn't have that pull down on it. I think that's where we're going to start anyway. We will start by putting these 100 ohm resistors in. So we've got 4 of those to go in, and they need to go on the inputs to the gates. So we'll put one in. Are we going to be best putting them in like that, or are we going to be best putting them in standing up? I'm just thinking, well, no, because we've not got a lot of room in there, or we'll have them sat down, I think. In fact, they should be alright going in like that, because we're going to need that hole there. No, that's not going to work. I think we will have to have them. You may have noticed I don't actually really plan my board layouts before I start. I just kind of, shall we say, make it up as I go along. Okay, so we're going to do that like, oh, it'll be alright. It won't be any higher than the actual chip in there. That'll be fine. So that's the first IC there. Sorry, the first gate on the IC. I need something to prop this board up as well while I populate. I tell you what I'm going to do. Because the whole reason I built the damn thing. We will get out my homemade helping hands. I think this needs a helping hand in itself. It's getting a bit loose and floppy. There we go. That might be good enough. Hopefully that'll be enough to hold it while we just get these components in there anyway. Some of the other arms on here are a little bit poorly. I don't think they're going to do what we want them to do. Let's see. Oh, there we go, that's working. That'll hold it enough for us to get the components we want in. You can still see what I'm doing, can't you? So it's going to be a case of forming them and dropping them in place. I have a feeling this is going to be one of my more long form videos. See, I do actually read the comments that people leave me, and I get half as many people saying they'd rather have shorter videos and half saying that they like the long videos. So all I can really do to keep everyone happy is do some videos shorter and some videos longer. Like I said, I have a feeling this one's going to be one of the longer ones. Right, so that's our thing. Oh, we're going to have to, we might have an intensity on the other side then, seeing we're going to have to utilise the other side because we've run out of gates on that side. We have 6 gates in this, and we need 4 of them. So we'll miss that pin out, and then it's going to be that pin there. In fact, we'll have that the other way around. Get in there. Go on, get in that hole. There we go. Right, so that's the 4 resistors in place. I'm wondering if I can sneakily just bend the legs over like that on that side. Are you going to bend over nicely as well? Hopefully, yep, there we go. Then what I hope I can do is I can flip it over and we can solder the other side in. And we're not going to solder this side in just yet. Let's see if we can flip it over and hopefully they're not going to drop out. No, them legs I've bent over are holding them nicely in place where we want them to be. Where's a little bit of solder? Clean off the soldering iron. That one, we'll get that pin while we're in here. There we go. So that's the a little bit more there. There we go. That's the first one in. Going for the next one. That one's in. I have to be a little bit careful here because obviously there's solder already on the board. Don't need to put too much on or else you're going to bridge some of the traces. There we go. Right, so that side, oh, we can do the other side while we're here. Where is, there it is. Make sure that that is through as far as it will go. Solder that and we'll just get the pin as well. There we go, so that's soldered in place. Let's flip that board over again and see what it looks like on that side. There, that doesn't look too bad. Yeah, I'm quite happy with that. That doesn't look too bad at all, that. We can trim off the excess on them. There's my good snips. Saying good snips, I need to buy some new side cutters because mine are all pretty much shot. Let's try these ones. These might be a little bit better than my proper side cutters are now. They're not brilliant, but they'll do the job. There we go. And that one there. Okay. So that's the first set of components then. That is the those 4 100 ohms there, so we might as well put the 75s in now to ground. So that's why I haven't put that other leg in yet. So what we're going to have to do is go from there. Unfortunately, this is not going. There's not going to be any really neat way of doing this. I don't think. In fact, let's make sure. Let's just remember which one's definitely ground. That side there is ground. There. That side there is VCC. So. Can we sneak in that hole there? Yes, we can. So this is the first one. See, 3 of these are going to be easy and 1 of them is going to be a little bit trickier. So that one's going to be alright in there. That goes between that point there and the ground. Can I get you in a bit better? There we go. I hope you can see what I'm trying to show you anyway. There we go. Now we need to go from that point in there to ground. And push that down like that. That doesn't look too bad. Now the next one's going to be the tricky one, because we need to be able to get a resistor from that centre point on that one to ground. I have gone in the right place here. And of course I've buggered up straight away. This is why I don't solder them in place right away. I'm actually going on the wrong side of that resistor there. I need to be on that side of it. So that's still going to work quite nicely. Down like that. Yeah, that'll work. Again, but this last one's going to be the slightly tricky one, because we need to get it from there over to one of the ground points without going through anything. How am I going to do this? We'll have to. I suppose what I could do actually, I've soldered the bloody thing in place now. Just thinking I could have used one of the gates over there and just made my life a lot easier, couldn't I? I can desolder that. You silly sod, you. Yeah, I would have been far better. This is one of the disadvantages of just doing it, rather than actually planning your circuit out on a piece of paper first. Is you realise your silly mistakes after you've made them. No, not that it's like hard to fix, but yeah, if we use that next gate down from there, so that's the input output, this input there, and we use that one instead. In fact, we could even use the last gate on there, couldn't we? Which would make it even easier to get to the ground, and it spaces it all out a bit more on the circuit. Yeah, you silly sod, why didn't I do that in the first place? That's the input. Yeah, because that's the ground there. VCC there, ground there, input, output. So we'll use that input there, like that. Bend that leg back over and we'll have to solder that in place. Which is going to be a little bit trickier because I've cut the leg short already, but we should still be able to just let's see if I can just tack that in place. This is where I need a third hand. Just bear with me while I just do this. I need to be able to hold the pin, the board, and solder at the same time, just because I've cut the. There we go, done. Ow, 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 that's hot, that's burning my finger. There we go. So we've moved it round, we've put it over there now. In fact, I'm just going to straighten that resistor up while I'm in here. No. Yeah, I'm happy with that. There we go. Right. And push that back down there. I'm happy with that in there. I'm happy with that in there. We can now add them last two 75 ohm resistors. So we need to go from that point there all the way over to that point there and push it down. And then we need to go from that point there again all the way over to that point there. No, not that point there. That point there next to it. These are really cheap resistors, by the way. The legs on them are like super thin. They're not like the resistors of old. I mean, the values are perfectly acceptable on them. They're in value and everything. It's just they are super cheap. They are really cheap resistors. Right, okay. I'm quite happy with that. That is everything where we need it to be. What we can do, in fact what I'm going to do now, is I'm going to solder the ground side of them resistors into place, and then I can snip that side of the leg off. So, one there, one there, one there, and one there. Right, okay, and get them snipped off now. Yeah, I really need some better snips. Okay. I think I'll resolder that one. I'm not quite. It's not quite flowed all the way around the leg there. And that's it. That should be better. That one, I think. No, I'll just reinforce the soldering around that one as well. There we go. Right. That'll be alright once it's down there. Yeah, they'll be okay. It raised up a little bit, but I can push it down, push the because these legs are so thin, I can basically push it along and lose the excess through the hole there. Just give them a little tug just to straighten them out on the other side. There we go. Right, now what I need to do is I need to be able to basically connect those together and bring them out to wherever I'm going to connect to the inputs from the monitor. Sorry, from the computer. What I might do to make a good connection. Now this I'm sure is not standard practice. Let's see, we've got two resistor leads right next to each other. I might actually twist them. Like that. And then flatten them down. And they basically make their own connection to the pin where I'm going to solder the wire to. hope you can, like I said, I'm a bit concerned about the lighting in here still, even though I've got a much brighter light than I had in my previous workspace. I'm still a little bit concerned about the lighting arrangements in here. Now we can solder that into place, and that makes the perfect point. Basically that is then these points here on the you can't see what I'm pointing at, it's basically these points here. Right, I'll go ahead and I'll do that to all four. I'll just get hold of it with the pliers, then we can get a nice tight twist right next to the where it comes through the PCB. That's also helping bend it down. Yeah, that's going to be ideal because that'll make a really good connection to when we connect the input wires. Okay. Push that down like that. I'll get that one back up now. Okay, there we go. Snip that off. So all we need to do now is just solder those into place, and that's our 4 input connections coming from the monitor. That's the first one. There we go. Oops. There we go. So those are ready to accept the wires coming in, like I said, from the actual computer. That's the four main wires. Sorry, 5, isn't it? Yeah, no, it's 4 main wires because the sync signal, we're just going to go straight across between the two, so that doesn't have to matter too much. Right, so basically, get the circuit back out. We've done all that bit of the circuit there. So now what we need to do is build this bit of the circuit here, which is the outputs, and we need to combine the intensity into each one, and that gives us our actual output. So let's get the circuit back in. Our outputs are basically the next pin down from where we've been. Now what we'll probably do, what we need is 560 from there, which is like I say, I had this part of the circuit already built up on the board, but I did remove it all. can put a 560 in. Which way around are we now? Yeah, so that's our output there. Just bear with me, have I cocked up here? No, I haven't, sorry. No. It's because I moved that thing over there. Just ignore me for the moment, I'm being an idiot. But basically we want to come off the output there to somewhere we can tie off to, so we will use that one there. Straighten this leg out a bit. There we go. Like I said, I did use these previously, so get in the hole. There you go. Right, so that's in the correct place. We will, just to make life a little bit easier, we'll try and bend that down because it's already only got very short legs on it. We'll have to be careful on that one because we'll need to get to the other pin. Right, so that's that first one in. Then we want the next one. That one's going to be a pain because of where we've put the that resistor there. I might have to jump over the top of that and not have it short, but not ideal, but it'll work. We're going to get that in the hole though. Again, this is going to be a tricky one to solder. Oops. Try and hold the iron somewhere. Did I get that? There we go. Got it. So that one was a little bit tricky because the leg was very short and I just needed to... I've had to hop over the top of that other component there, which is not ideal, but it's it'll work. In fact, I won't solder that in place until we put the next component in place. I'm probably going to have to do the same thing again actually when I get to this point here. Right, so yes, I will. I'll have to do something similar here. So we've got one in there, one in there. We need to have decide which one of these is going to be the intensity gate. We'll say that that one at the top there is going to be the intensity gate. We'll use this one here. Yeah, we'll use... In fact, no, if we use that one as the colour and that bottom one as the intensity, we won't have that problem with the resistors getting in the way. So we'll go in there. Ow! Ooh, it's got the end of my finger with a soldering iron. Right. Get this in place. Got ya. This one I should be able to just bend into place and then solder normally. So we can bend that down there. We'll bend that up there. Okay, there we go. I've just done it again. I've just touched the end of the soldering iron again. Oh yeah, smell of burnt flesh, lovely. Right, let's get that soldered into place. There we go. I think we should be about right there. So that is, I need to solder that one into place yet. That's just being held there for now. Let me just get that one soldered into place, at least on that side. Where is it now? It's that one there. There we go. Yeah, that's got that one. So that's our three 560 ohm resistors put in place. We now need to fit our 1K resistors, and they all need to come off the output from the gate, which is going to be the intensity pin, which I have decided is going to be that bottom one there. So we need to bring that out to somewhere where it's a little bit more usable. So what we might do, solder that into place, and we might just use some of these pins over here for the actual resistors, because basically one, yeah, we'll do that. What we'll do, that's going to be the output. We'll go over here. We'll put one in there. Oops. One in the next one. And one in the next one. Like that. I can hold them down, spin it over, and what we want to do basically is connect all those over to that intensity pin over there. Well, what got the gate that is going to be driven by the intensity pin. So let's bend one, bend them, and we can solder them into place. That'll hold them in place in a second. Like that. So that's going to hold them in place. I just realised I've made a mistake yet again. Hopefully it's an easy one to correct. Yeah. That last one there I've put in the wrong hole. It should be in the next hole along, so hopefully we can pull that out of there and put it in that one there. Lovely, and that's going to work nicely. So all we need to do now is connect basically those up from there to that intensity pin, which is the last pin over there. And we can do that with a little piece of wire. Let's see if I've got a little piece of hookup wire. Yeah, I have. Use a little bit of this yellow here. Try to avoid as I like as fewer little wires as possible, really, but sometimes it's unavoidable. In fact, I might just be able to strip the insulation off this and just feed this up through and down, because it goes underneath that resistor there. Let's see if we can do this. Go up through there, and we want to come back round, unless I just do it on the back and just literally just put a piece across. I could do that actually. Why we're making it overly complicated when we don't have to. All we need to do is make a bridge between those two connections there. In fact, we could just use this component leg, couldn't we? That'd work just as well. We want to go between that point there and that point there with it, like that. So let's just do that instead. That'll make life a lot easier. There we go, that's soldered in place on that side. So that's the output of that gate, and that needs to go to this bank of 1k resistors we've put in there. Just snip that leg down a little bit. We can just solder that down. Down to there like that, and that'll be fine. I mean, none of this is high current, it's just signal path, so providing it's connected, it should be fine. There we go, that'll work nicely. Right, excellent. So we've got the intensity pin there connected through to those resistors, and the outputs of resistors on those three pads there. That's perfect. So basically all we need to do now is connect from there to each one of the outputs of them 560 ohm resistors. So there, there and there, we need a wire from there, there and there, and that's basically going to be it. That is then there, that point there, that point there and that point there will be our outputs, and we know our input is there, there, there and there. and that should work. That should basically be just that in real form. And it doesn't look too nasty under there anyway. So I will get some wire. We can use this actually. This should be absolutely fine. It's a very fine wire, but it won't matter. We'll start with that one there. In fact, it will even go through the same hole as the component leg. Try soldering that in place. Okay. That's from the first one, and that needs to go to that point there. So we'll cut it off a little bit long, like that, and strip off the insulation. There we go. Pop that down there. It has to go in that hole there. That's going to be the output anyway, so that won't matter. We'll solder that in place there, and cut the excess off, and that's basically the first one done. Where is it now? There. Oh, yeah. That's it. We'll cut that excess off. Okay, so that's the first one done. So we're going to have to run a few little wires like that, just from each one of those resistors to each of those points there. In fact, I'm probably just going to do it quickly off camera, because I've just noticed I've only got about 20 minutes left on this memory stick, and if I use all this stick up, the video will be just over an hour, and I think that hopefully should be just about right for this. So I'm just going to quickly solder the other two ones of them in, and I'll get the other bits of wiring we need in here, and then we'll just quickly come back and finish this thing off, get the 5 volts into it and things like that. So back in a sec. Okay, I just thought I'd quickly bring you back to show you the end result. So basically this is all the wires. That's the connector that goes to the Amstrad. So that's all the inputs basically connected. So as you can see, we've got our red there that goes to that 75 ohm resistor, and the 100 ohm resistor that goes to ground, and then that goes to the first gate, out of the gate, through that 570 to the 1K, and then we've got our output to generate from that. Right, so what I will do, I've just actually realised that the cable I was going to use for the power I've left upstairs, so I'm going to go and quickly grab that, and then I will start looking at putting the output leads on. I'll probably do one on camera and then just finish them off, and then we can come back and we can actually give this thing a test and see whether it is going to work, so keep your fingers crossed. Anyway, back in a sec. Right, we're back, and I've got a cable I can use for the USB. I always, if I scrap anything that's got a USB cable on it, like an old keyboard or something, I always cut the cable off, because these are incredibly handy, especially seeing everything we're working with is 5 volt logic, and we've got a really useful 5 volt supply with that. I'll connect the sync one up first because that's dead easy, because that doesn't actually have to go through the circuit at all. So we need to go into there, and the ground needs to connect to the ground point. We'll use whichever one of these we can get the ground in. There we go. And just solder them in place. That sync wire, I'll just see if I can bend that over, and we need to solder those two together. Yeah, that'll do. And we'll get the ground soldered in while we're here. There we go. Right, so that's the first of those connected up. Yeah, that'll be nice and decent there. I'll do one more now, and then I'll do the last ones off camera just to save a bit of time. I've got red here. This, if you was making this yourself, you could have this as a SCART connector and do it that way, but you'll have to, if you was going to do that, you'd have to implement some way of doing the RGB switching as well, which I've already got taken care of by my little breakout box up there. This one, what should I say, this is red, so that needs to go to that pin there. And that also needs to go to a ground. That can go into that ground there. So we'll solder those two in. Now where's my solder? I need some more solder. I think I've run out of little bits of solder, have I? I was trying to use up all my little bits of solder, but I think I've used them all now. Where's my roll of solder gone? I don't know where my roll of solder's gone. Just bear with me a second, folks. I was sure it was on the desk here. You know, sometimes you just wonder where things disappear to. You're working. I'm sure there's a little elf in here that wanders around moving things as my back's turned. Ah, there's a piece of solder here, that'll do. Then I'll have to hunt out where my roll of solder's gone. I've got enough to finish the project here, I think. I'll solder that into place. There we go. And solder its ground in. Right, I'll just to save a little bit of time, I'll just do the last two wires off camera. It's exactly the same as you've just seen me do there, and I'll connect the USB up for the power, and we'll come back when we've got it all connected up and we're ready for a quick inspection and a test. So back in a sec. Okay, and there we have it all finished and wired up. I have made one addition. I've actually added a little LED to it just so we know when it's powered up, you know it is powered up. And in fact, if I just connect it up now to a 5-volt source, there we go, you can see it actually does power up. Now I've not got the IC in there yet. In fact, that's the next thing we want to do. I will just that's it. That one there will do, I think. I think it's got to be a HC, a 74 HC04 and rather than an LS04. I believe that's what they used in the Amstrad monitor. And I do have a HC04 right here. So we'll stick that in. And I hope I've got all this connected up correctly. So push that in there like that. And I'll just power it up and just make sure that's alright before we go any further. So that seems fine. I mean, if we had that wired up wrong, that'd be getting burning hot straight away, so no, that's staying. I think we've got everything pretty much right there anyway. So the next thing to do really is I'll clear the desk off. I will get the Amstrad motherboard back out, and we will actually give this thing a try and see if it gives us a decent image on that TV. And if it does, and I'm happy with it, we'll have a look at actually putting this thing in a case and making it like a permanent little project. So back in a sec. Okay, I've got all the test setup rigged up here now. So I've got the main board set up, I've got our little circuit set up, I've got the TV switched on, which is just off shot. In fact, I'll put you up on the screen. Actually, that would be the best thing for you to see, wouldn't it? So there's the screen. Yeah, that's in focus. You can see that. So what I need to do is I need to first of all plug the little adapter box in, which will put the TV into RGB mode. So I'll connect that. Okay, that's connected, and then I need to connect the little circuit that we've just, I've just put together. Okay, that's connected, and you saw a little flicker on the screen then. And then I will switch on the Amstrad motherboard. So that's the motherboard switched on, and all being well, fingers crossed, there we go, it's working. Obviously, like I say, it doesn't quite show properly on this screen. I'd have to mess about with the geometry of the screen to get it to work properly, but there we go, it works. It's actually, well, because it's in black and white, as you see we've got white text, it means that it is working in colour, if you know what I mean. We can't prove that really yet until we go a little bit further with the project and we actually get the Amstrad back in a case, back hooked up to some drives and things like that. But what this proves is we have now a viable solution for getting video off the Amstrad and actually onto a screen so we can see what we're doing. So next thing I need to do is make that look a little bit prettier, and I'm going to see if I can mount it in this old modem box. I think that would make a reasonable enclosure for it, and because it's got a little light pipe there, hopefully the LED will show through and we should at least be able to see that the thing is functioning. So I'll have a quick fiddle about getting this thing finished off and fitted in here, and I'll be back as soon as I've got a little bit of progress. So back in a sec. Okay, and there is the finished result. Basically, I've got all the wires all nice and neat, and what I've done is I used my drill. I drilled a couple of holes in the back of the case there and just passed a cable tie through, so that secures everything nice and tight in place there. I had to just use a file and just file a little notch in the back of the board there to get the board to come forward, further enough forward so it just sits in front of that notch in the case there, which is basically how the original board in this sat. So hopefully, fingers crossed, now I haven't actually tried this yet, I thought I'd try it on camera. Tempting fate here. I'm just hoping that this top will actually now fit securely back on there. So, like I said, keep your fingers crossed. As far as I can see, it should do, but it's just a case of making sure that the board doesn't slip back while I try and get this in position. And then the actual case itself should hold everything and stop it from moving. We get them in there. Oh yeah. I think we've got it. Yeah. Right, I'll put that screw in the back. That's got it. Lovely. So there we go. That's the finished result. So we've got our wire there. Let me get you zoomed out a bit. So we've got our wire there to go into the back of the amp. In fact, we need to test this, make sure we haven't disturbed or done anything while we put it in the case. So that goes into the back of the Amstrad like that. Those wires go off. Like I said, you could have a SCART on there if you wanted. The only thing is you'd have to find a way of switching the RGB. You've got 5 volts in there. You'd need what I can't remember off the top of my head, but you need a small ohm resistor, like 100 ohm, 200 ohm, something like that resistor, onto the is it pin 16 of the SCART, I think, 16 and 80, I can't remember off the top of my head, so you'll have to check that out. But basically the RGB blanking pin on the SCART, and you could have a SCART wire off the end of this rather than what I've got, which is it basically goes up to this little box I've got here. It's an old, I think this come from Gadget UK actually. I think it came in a box of bits that he gave me years ago. But basically it's just a SCART breakout box, and what I've done is I added BNC sockets to it. It's got a SCART coming out of the back, so I can use it to plug into a SCART TV and connect something that I've got on with BNCs on it. I can also use it with the S4000 with a set of BNCs plugged into there and into the front console on the S4000, and then plug leads in that are designed with a SCART connector into there and use it as an either way adapter basically. And this has just a USB coming off it, which gets that switches the RGB blanking, so you don't have to worry about the appliance or whatever signal you use in doing that. Like I said, that's just done using that simple USB there. So that's how I've got it connected up. Anyway, I've got it all connected back up again. We will switch back on, and we'll hopefully we will get a signal back on there again. So I'll plug it all back up. In fact, let's see if we can see the LED on the front. I don't know if it's going to show through. I should have used a brighter LED actually. No, it doesn't really show through, unfortunately. I should have used a brighter LED for that. But anyway, let's switch the Amstrad back on, and hopefully we'll see it count up again. Yes, there we go. So it's definitely working. Yeah, I should have used a brighter LED than the one I had. I do have some ultra bright green LEDs as well. I may swap that, but that is working. Well, for the moment, for the amount it's working, I'm happy with that, and that will allow us to carry on with. In fact, let me get you round and zoomed out and looking at me rather than looking at that. There I am. Switch that back off. I can unplug them from my laptop. I'm just using my laptop there to power them all. That's why I like using USB to power devices like this, because USB is everywhere now. So you could use a power bank, you could use just a 13 amp to USB adapter, or just plug it into the USB on your laptop. You're just parasiting 5 volts off it. And we're not even talking a lot of current with what we're doing here now. You know, it's literally all we're using that 5 volts to do is to power up that 7404 in there. Again, with the RGB switching, all we're doing is sending a tiny little voltage signal. It goes through a potential divider, and it sees about 2 volts or something like that to switch the RGB blanking signal. So yeah, basically I'm super pleased with that. We do have now a solution to actually get an image on the screen. I am probably going to build another circuit as well as this one. Like I said, this is handy. This means I could plug it into a modern LCD TV with a SCART on it and it would work. The problem is brown. As simple as that. Brown is an issue. What this circuit can't do is do the colour correct for brown. What it was basically when the original CGA standard came out, brown comes out as yellow. And what IBM did, and what actually a few other manufacturers do, I believe the Commodore 128 is the same as this, because that uses the CGA standard for its video out. Of the colours, like I said, one of the colours, it comes out as yellow and it should really be brown. And how IBM got around it was to actually implement some circuitry in the monitor itself, which changes that yellow colour to a brown colour. I think it adds red to it, or it does something with a little bit of magic circuitry in the actual monitor to get around that. And all CJ monitors, all proper CJ monitors, do that. And in fact, that's the thing, that sometimes you'll get a CJ monitor that doesn't, and it's the fact that it's just like a bad copy of a CJ. It doesn't have that little bit of hardware in there. And obviously, what I've done doesn't do that. It will just produce the yellow colour, the orange colour, yeah, yellow colour, sorry, instead of the brown. What I'm going to do is I'm going to make another little circuit up, something similar, but it's going to use that LM1881 to get around the H-Sync and V-Sync issue, and allow me to connect the Amstrad up to that CJ EGA monitor I've got, which does have the brown signal colour correct in it. Just so I can see it with the proper browns if I want to, but like I say, I've still got the option of connecting it up to any other analog monitor I want. But like I say, it does then give me the option of connecting it up to that nice little EGA monitor that I've got. Like I said, in the future, if I ever do manage to get a 1640 board, we've got an EGA monitor, so we could actually get the full EGA effect. Plus, I want to get an EGA card anyway for my 286, my Zenith 286, because I'd love to use that monitor on that Zenith 286 when I finally get that out of storage and back into functioning operation. Anyway, I'm going to leave it there for this video, because it's already going to be a long one. I think I've covered everything I really wanted to cover on this video. Super pleased with the results. Like I said, we've got something we can work on with. In the next video I'm doing on the Amstrad project, we'll probably be getting the computer back together to some point and actually seeing if we can perhaps, you know, get it to boot, actually get it to run some software or something. So I'm going to say, hope you enjoyed that. Thanks for watching, and goodbye.